By the day of the test, yes. Alright, so you guys, let me know if it, well, I'm only going to talk for a few minutes anyway. It'll be alright. Alright guys, so any questions from homework stuff? Yes, ma'am. Anybody just coming in?
On chapter 2, section
2 point?
Chapter 2, section 1.
2-1? Number
54.
54.
Looks simple, but I don't know.
Oh! Alright. So let me show you a few examples. If I said solve this for y, what would you do?
2.
No, you wouldn't do 2. What would you do?
No, divide by 6.
Divide by 6, okay, good. And say what's the answer? Say what would you do? What you do is more important than what the answer is. So what about if I had said 9y equals 3? What would you do? Divide by 9, right? Even though 9 doesn't go into 3 evenly, who cares? You do what gets the variable by itself, right? So you would divide by 9. So you get what?
1/3.
1/3. There you go, that's better. So people tell me the answer here is 3 because they didn't actually do the work. Their brain just said 3 goes into 9 3 times. No, but the answer is 1/3. All right, how are we doing so far? Because we're the humans. We say we divide. No, so what if I would have put a 10 there? What would you have done? What if I put 187 there? What would you have done? All right. So what if I put? I'm sorry. What if I put an A there? What would you do? Bless you. Yeah, you divide by A. You do whatever. Bless you. You do the opposite of why the variable is not by itself. So why is the variable not by itself? It's multiplying by A. So I divide by A. Cool. Yeah.
How do you know? Okay, so I know 12 over 6, it would be 2, but how do you know if you're supposed to break it down all the way? Because on some of them, like, we didn't do that when we were...
No, I always.
Oh.
Never. 12 over 6 is never acceptable. Technically, you could argue it's the right answer, but it's like you're giving me a problem to figure out. No, you're supposed to do all the work. So 12 divided by 6 is 2. 3 divided by 9 is 1/3.
Okay.
If it reduces, you reduce.
Yes, exactly. Cool. Right? Don't give me a problem as the answer and make me figure it out. No, that's not my job. I've done that enough in my life. Yeah. Anybody else about
You
this
just wouldn't do it if it wasn't going to be a mixed number, correct? Because then that would be different.
Oh, if it doesn't say, so, I mean,
So what if it's 13?
if I had 10x equals 16, right? Oh, let's make it 11 just so it doesn't. So then I divide by 11. If you want to write that as a mixed number, you can. If it doesn't specify, I don't care.
Okay.
So those are both, as long as it's a mixed number, that's reduced, right?
Okay.
You guys with me? Whoever asked that question, do you see what to do now? What would I get here? What would I do again? Divide by whatever's with the y. So what do I get? What is b divided by a? It's b divided by a. I don't know what the hell it is. Don't say c. You don't know if that's true or not. Just say b divided by a. Kick ass. Is that all right? So this is what I mean by the process is what matters. The process doesn't care that there's no numbers in there. The process says, why is that not by itself? Make it by itself. And then whatever you got to do to make that happen, you just deal with what happens. You guys understand? This is really important because the people that get that get math. Right? This is why you don't have to memorize a billion different things, because a million of those billion are all the same problem. You just got to remember the process that ties them all together. Yeah. I'm sorry. Did I skip something? You had a question. Yeah.
Yeah, but section 2.2, 60 to 75. How we have with that?
Oh, look at you getting as much as you can out of it. Which ones? Sorry?
As about folds and samples.
Does it have no solution, one solution, that one? 61 through 70, it says, does it have no solution, one solution, or infinitely many? Okay.
Maybe 67 is the same question. I just want to know if I did it right.
Number 60
Yeah.
is different.
Oh,
But-
I
but
thought it was the same.
It's sort of like that one.
Yeah, I got.
So let me start with 60, and then I'll do, because 60 is like the one we just did.
Okay.
So 60 is the exact same thing. Let me show you. If I had 1/7 x plus 2 equals 4,
Right.
what's your gut tell you? What should you do first?
Get rid of the fraction.
No, well, you could, but
Multiply by 7.
I could subtract.
Oh,
subtract
times
two.
two.
Do you guys see that?
Okay.
You could multiply by 7, certainly you could. You don't really have to. But either way you do it, you can get these guys together, because the last thing I can do is, how do I get rid of that 1/7? Multiply by 7, yeah. And you guys cool with this? You're supposed to divide by whatever's in front, right? What's dividing by 1/7? If I divide by 1/7, that's the same thing as multiplying by 7. Cool, I like it. So you almost always divide last, which is the same as multiplying by the reciprocal. So there you get 14. So the actual problem is this.
I guess I confused myself.
Oh, it's even weirder because there's a 0 there.
Yeah. Because A is 0.
No, A is not 0. No. It says,
Yeah, 0.
why would A be 0?
Hold on. Maybe that's probably why I confused myself. That's what I saw.
The problem before that says A not equal to 0.
So it's negative BA?
No. What are the steps? What would you do? What's the first thing we would do related to that? What's the first thing you do? Add B. You guys, so you cannot, just because there are no numbers in here, doesn't mean that you have to solve it differently. You guys see what I'm saying? The process does not care what's in there. What did I do first? I got rid of that number. What do I do first then? I get rid of this, whatever that number is. I get rid of it. I get my X piece by itself first. So add B. And then what would I do?
Multiply by
Multiply by A, yeah, exactly. Multiply by A over 1 if you want, sure. So you get X equals
Yeah.
BA or AB or BA, it doesn't matter. I really want you guys to understand. That's what people freak out when there's no numbers in a problem. People freak out, but we're about to do a section. The whole section is all about having no numbers in an equation. Who cares? The steps you take don't change. The steps you take are always the same. We're the humans. We don't let the problem tell us what to do. We tell the problem what to do. Screw your problem. Do what I want. All right. Yes. Say again?
63.
Okay, so let's go to this next section here. Oh, this one, yeah, this one freaks people out. But again, if again, you guys are gonna be like, oh God, not again. What would I do here? What would I do here? Okay, so what do I do here? See, here's a shit. I don't care what's over there. Would you do something different if I put a 4 here? No, you still divide by 6, right? It doesn't matter. What matters is why is the X not by itself? It's multiplied by 8, so what do I do to both sides? Divide by 8. Now what is 0 divided by 8? 0, not undefined. It's only undefined if the 0 is on the bottom. Cool. So don't let 0 completely freak you out. I know 0 is sometimes freaky, but sometimes it's way too easy. 8 times what is 0? What do you multiply 8 by to get 0?
0.
Yeah, that's why we got the answer 0. That's because that's what you do. You multiply by 0 to get 0.
So should we put like this has one solution?
Oh, yeah, well, how many solutions does it have?
One.
There. So they're not saying, the instructions don't mean don't solve it. The instructions mean solve it and then tell me what you found. I found one answer. What would I get at the end to have an infinite number of answers? What would I get at the end? All right, let me try like this. What does this mean? If I work a problem out and I get this, that means what? No solution. Now, so what kind of thing would I end up at to have an answer of infinite number of answers, or all real numbers? 1 equals 1. So you solve them like always. It's just the instructions are trying to warn you, hey, some of these might be freaky. Right? That's why the instructions are there. Some of these might be freaky. Solve them like always. If you get this, no solution. If you get 1 equals 1 or 7 equals 7 or something that's true, all real numbers. If you get this, one answer. What answer? The one that it says. Maybe. Yes, ma'am.
Okay, so if you have parentheses, and there's a number outside parentheses, inside parentheses there's a variable plus 1 and another parentheses.
Let's make a problem.
Okay.
So something like 4 times x minus 3.
Yeah, are you still going to go 4x minus, and then multiply the 12?
definitely.
So you
You
still
have to, or else it wouldn't be
even
true.
if it's a variable there?
Totally.
Okay.
Yeah, in fact,
Sure, something
I
like
really
that.
want this to make sense. If it wasn't a variable there, I would not distribute. No, you could. Distributed property should work always. But why do I not need to distribute? Because I know what 2 minus 3 is. Why did we create the distributive property then? Because if I can't do order operations, what's x minus 3? I don't freaking know. Shoelace? I don't know what x minus 3 is. So then I distribute. It's a way that I can reorganize the problem so I can actually do something. Right? Then you distribute. Here, please, dear God, don't distribute. That's what messes people up. You don't need to. It still works. What do you get if you do the inside first?
-1.
So -4, right? Now let's try to distribute. What do you get here? 8.
12.
And what's 8 minus 12? -4, right? So it's got to end up with the same answer, but which one was easier? This freaking way. Combine it, make a number out of it. You're almost done, right? So distributive property's got to be true always, but the only time you have to use it is when you can't do the inside. That's what order of operations wants you to do. I can't, so I needed a way around it, so then that would be, of course, minus 12. Yes?
And then number 16.
16. We just did 16.
Oh, did you?
Yes. It's not up here yet, still.
That's okay.
Okay. Anything else from homework?
Can we do 69? That's another question.
All right. You guys take a minute. If you haven't done this yet, do it.
The answer is 0x.
The answer is what? No.
Are we still on 2.2?
Yes. All right, you guys take a second and do that. You get tired, didn't your work for you? Do that. This is section 2.2, number 69. While you guys are doing that, anybody not get the word problems handout from last time?
Did we get a word problems? Or is this it? Did we get one that was blank?
Oh shit. Well, you weren't here last time. Yes. Well, let's see. Something's got to You need one? Anybody else need one? You both of them. How many you got? Alright. Is that everybody? You didn't get no solution, you got an answer. You got 13 over 4. Right. And the reason is, what do you have to do here? There's a parenthesis. Yeah. Alright guys, so, what's the very first thing you have to do? Distribute it. I like it. Because there's an understood what here? So you multiply the -1 in, so you get x minus 3x minus 2. So over here you can do what? Yeah.
Minus 2x.
Negative 2x.
Negative 2.
Added 3x.
What happened? Are we good? Just to keep it straight. Now there's a million different ways you can do a word problem, but if you do it by the book, just to get comfortable with it, you simplify each side and then you start moving stuff around, right? So how do I get the x's together? What do I have to do to make them disappear? Add 2x. Add 2x. Don't freak out. Everything cancels, right? All the x's cancel. So what do you get? So the math is not trying to tell me -2 is 15. The math is trying to tell me, well, if you could do that, then I can do this. That's what math is saying. If that's true, then this is true. Well, is this ever true? No. So that is never true. So the answer is no solution. Done. Yes.
Oh, never mind.
Okay. This is the answer. Circle that. Don't circle negative 2 is 15. Yeah.
I came up with 0 equals 17.
Sure. I love it. If I add 2 to both sides, what do I get? 0 equals 17. If I subtract 11 from both sides, I get negative 11 equals 6. You can swoosh them all over the place, but swoosh it that way, swoosh it that way. Whatever the hell you do, it's going to be there's no way to make them equal. Is that cool? There's no way to make those equal. And no matter what you do, you end up with something not equal to something it's not equal to. So it's not true. I like it. Yes?
Another question?
Sure.
75 and 72.
Alright, so they're both basically the same. So this is really a problem about, this is not a word problem, because they gave you the formula. Yes?
So if you do not simplify it before you start moving stuff around, you can get a different answer.
No. So before we do that one, because I think you said to add 3x here?
Yeah,
Right.
I just had x minus 2, which is pretty stupid, but it,
No. Let's do it. Nothing wrong with not. You got to end up with the same answer. So if we add 3x, what do I get? Those cancel, so I get x minus 2
x minus 2
equals.
equals 15 minus x.
No. Negative 2 plus 3 is positive x, right?
That's what I messed up.
There you go. And your x is still canceled. So even if you do it a slightly different way, as long as it's legal, you got to end up with the same answer. Which is what some people say they like about math, that there's only one answer. But when you get far enough in math, there's not always just one answer. It's cool. Math becomes more real. Like probability. Well, there's a chance it's this. Like anybody paying attention to the election. Please tell me you are. Or it's almost impossible not to, right? Is anybody going to vote for the first time? All right. Is anybody else going to vote? Everybody going to vote? You're all like, good luck. But real quick, you ever seen a poll where they said like candidate A has 44%, candidate B has 40%? What do they always have at the bottom of the screen? You ever seen at the bottom of the screen they have plus or minus 4%, right? Give or take. So like, we're not sure, let's just add something in. So if you ever take statistics, I would teach you how they get that number. And that's why statistics is the most honest math there is. It says, the answer looks like it could be this, give or take, right? Anyway, sorry, just want to go off on a tangent. You don't always get an exact answer in math, because sometimes math is very honest, because life doesn't always have answers, right? Life is sort of like, shit, maybe this will work. But in algebra, you definitely always get one answer, right? Or an answer, some kind of solution. How are we doing? Anything else? What did you were asking? Okay, let's look at 75, because 70 is the exact same thing. 75 says, they give you this formula. So somebody with a book, help me out. What does N mean? And what does X mean? What's N mean?
The number of state and federal inmates.
Beautiful. The number of inmates.
Millions.
I like it, in millions. And what does X represent?
Sorry.
X is
It's
greater than
during
or
the year.
equal to 2002.
But it's the year. I like it. It starts in 2002. All right, so they're being honest about how far this equation works. You can't go back further than 2002. So X is the year beyond 2002. All right, I like it. So what do they ask you to figure out? They say, determine the year in which there were 1.5 million inmates. So the whole problem becomes, what do you do with 1.5? That's it. That's what the problem is. So where does 1.5, they want to know when was there 1.5 million inmates? So which variable would that go in for? N, because N is the number of inmates in millions. So what exactly would you put here?
1.5.
1.5. Good, not million. Don't put the zeros in. Don't, because it's in millions, so 1.5, and then you just solve for x. That's it. It's really just plug the number in the right place. So you got to pay attention to what the variables mean. So you put 1.5 in the right place. If you put 1.5 there, you're saying it's the year 1.5 AD. How many inmates were there? No, you went a little too far back. Yes?
How do you get 1.5 again?
They told me in the problem. They said, determine the year when there were 1.5 million inmates. So the whole problem is, what do you do with that 1.5? That's the problem. It's not a word problem. I didn't have to create the formula. They gave me the formula. It's just a plug and shove. Yes?
How'd you get this 0.03x?
I didn't. They gave it to me.
Where?
In the problem. I don't know how else to say
Oh,
that.
because it's split. It's on the next row. It's just a
Yeah.
Oh,
See,
okay.
I mean,
Never mind.
yeah.
Just kidding.
Otherwise, the question is weird then.
Yeah. Just stop that where.
Where? And you're like, Florida? Florida's normally a good answer when they talk about inmates. Poor Florida. All right. All right. Anything else from homework? All right, let's play. So let's do this. Everybody's got that word problem handout. You can have it out to help you. I want you to work in groups. If you really don't want to work together, fine. Be a wolf pack of one. This is all about word problems. So there's 4 word problems on here I want you to figure out using algebra. So don't forget, this is not a quiz. I'm not going to take these from you. This is to help you get ready for the quiz that we'll have on Thursday. I want something where I can push a button and they just drop from the ceiling, like oxygen masks. That would be awesome.
I
Great.
just have to verify, instead of pulling it back out, you can't make up quizzes, or you can.
Oh,
I have to do a training on
so guys, if you have to miss a quiz, I don't do makeup quizzes because too many people miss a quiz. I don't want to keep track of all that shit. Your next test grade will also count in place of your missing quiz grade. All right, so it won't be a 0. Your next test will just be count a little more.